This is the monthly review from semester 2. The subject is chemistry for grade 9. The first thing we learnt in semester 2 was ionic bonding. Remember, this is an electrostatic force between two opposite charged ions. So it's between a metal and a non-metal. A metal is normally found in column 1 or 2, or group 1 and 2, and it tends to lose electrons. Remember, when you lose electrons, you form a positive ion, while a non-metal is found in column 13 to 17, which is group 3 to 7, and these tend to gain electrons. Remember, when we gain electrons, it forms a negative ion. So this is different than covalent bonding, which happens between two non-metals. So don't mix this up with covalent bonding, which happens between two non-metals, while ionic bonds happen between metal and non-metal. An example of ionic bonding is NaCl. So Na, when we write its electron configuration, so here's given the atomic number, and remember in a neutral atom, number of protons equals the number of electrons. So we can write the electron configuration. So it's K2L8 M1, and remember this M1 here means it's in group 1. Okay, and group 1 are metals. It's in group 1, and group 1 is a metal. So it will lose an electron. So Na would rather lose that electron, 1 electron, than gain 7 electrons. So think about it like that. It needs to have a full outer shell, so if it loses that 1 electron, it will be K2L8. If it lost also an electron, it will become a positive ion, and it will be Na+. Cl has a atomic number of 17. So in a neutral atom, remember, number of protons equals the number of electrons. So when we write the electron configuration, it will be K2L8 M7. So this 7 here shows us it's in group 7. Remember, group 7 is a non-metal. So we've got now a bonding between a metal and a non-metal. So we know it's a ionic bond. So M7, it would rather gain 1 electron than lose those 7 electrons. Remember, it needs to satisfy the octet rule, so it'd rather gain this 1 electron to become 8 than lose the 7 electrons. So when it gains an electron, it will become negatively charged, and it will have a charge of Cl minus, the minus that we can see here. So one question will be, draw the Lewis dot symbol. So we've got Na. Remember, we know how to draw the Lewis dot symbol. It's got 1 electron in its outer shell, so we put 1 electron and represent that by a dot. So and then we've got Cl. Okay, so Cl has got 7 electrons. So we draw 7 electrons. Remember, first row 1, 2, 3, 4, 5, 6, 7. To make it easier for us, we can join those 2 dots like this. Okay, so we can join the 2 dots. Okay, the line's a bit thick here, but it's not meant to be that thick. Okay, and what we do now is this Na will give its electron to the Cl. Okay, so at the end of result we'll have is an Na plus, and then Cl, we put it in between brackets, and look what we have to do here. So we've got the electrons as we know them, but Na has given an electron to Cl, so we have to represent it in a different way. So rather than doing a dot, we put an X. So this shows us that it's got an electron from Cl, from the Na, and then to show that the whole Cl has a negative charge. We then do the chemical formula. So Na has a plus charge, Cl has a minus charge. This plus is going to go here, and this minus is going to go here. So we just literally like cross multiply. The plus and minus is just literally saying plus 1 and Cl minus 1, so we just write it like this. Next question might be explain the bond formation. So literally we're writing into text what we just did. The Na atom had one valence electron. Remember, it ended with N1. Okay, so it had one valence electron, one electron in its outer energy shell. The sodium atom needs to lose its valence electron to satisfy the octet rule. Remember, it's K2 and then it becomes K2L8. That's the octet rule, and to become Na+. The Cl atom has 7 valence electrons, and the chlorine atom gains 1 electron to satisfy the octet rule and becomes Cl-. There's an electrostatic force between the oppositely charged Na+ ion and Cl- forming an ionic bond. So literally this is what we write to explain the bond formation. It's just a summary of what we did. Our next lesson was electrochemistry, and we looked at oxidation numbers. Oxidation numbers let us know if there's a transfer of electrons. So if there's a change in our oxidation numbers, it means that there is a redox reaction, and if there is no change in oxidation numbers, that means there is no redox reaction. So the definition of oxidation number is, it indicates how many electrons are shared, lost or gained by an atom. It's related to the position of the element in the periodic table. So how do we assign oxidation numbers? The pure elements, so for example, if we have Fe or I2, Cl2 or O2, the oxidation number for them is 0. So anything that you see, like for example Mg, the oxidation number for it is 0. So any pure element by itself, the oxidation number of it is always 0. So assignment of oxidation numbers for the monoatomic ions, so that's equal to its charge. For example, you've got Cl-. The charge is minus by itself, so the oxidation number is -1. The oxygen has a charge of 2-, so the oxidation number is -2. The Na has a charge of plus, so plus means the oxidation number is +1. F has an oxidation number of charge of minus, so the oxidation number of F is -1. So then we have the oxidation numbers when atoms are in compounds. So all elements in column 1 have an oxidation number of +1. All elements in column 2 have an oxidation number of +2. Al in compound is always +3. The F in compound, so fluorine in compound, is -1. The oxygen in compound is -2, unless it's H2O2. The oxidation number of oxygen in H2O2 is -1, and hydrogen with a non-metal, the oxidation number for it is +1. So these are key terms that you need to know. Oxidation, oxidized, reducing agent, reductant, all means loss of electrons. And how I remember that oxidation means loss of electrons is with the acronym OIL. So oxidation is the loss of electrons. Reduction, reduced, oxidizing agent and oxidant all means gains of electrons. So reduction, how I remember reduction is gain of electrons, is by the acronym RIG. So reduction is gain of electrons. So example 1, how do I assign oxidation numbers? How do I know it's a redox reactions? It's shown here. So for example, we've got 2 Mg. Remember, we don't look at the numbers at front. So Mg is a pure element, so the oxidation number is 0. O2, the oxidation number for it, O2 is also a pure element, so the oxidation number for it is 0. And then we have MgO. Now MgO is in compound, right? So we can use this equation. So we've seen it so many times before in class. Oxidation number of Mg plus the oxidation number of oxygen equals 0. Now we know that the oxidation number of oxygen is -2, unless it's in H2O2, it's -1. But here it's not in H2O2, it's in MgO, so therefore the oxidation number of oxygen is -2, which also equals 0. Now to get to the oxidation number of Mg, remember this is always capital letter, we have to rearrange the equation. So the oxidation number for Mg is +2. Now we have found out the oxidation number of Mg is +2. Normally we write oxidation numbers in Roman numerals, and the oxidation number of oxygen we already know, which is -2. Now look what's happened here. We go to Mg, we look at Mg specifically, okay? Mg here before the reactants, and then we look at the products. So Mg went from 0 to +2, so the oxidation number increased. While with oxygen, it went from 0 to -2, so the oxidation number decreased. Now remember, oxidation number increased. It went from 0 to +2. That means electrons were removed. So remember our acronym, oil rig. Oxidation is loss of electrons, and for it to go from 0 to +2, it must have had to lose electrons. So we write the oxidation number for magnesium has increased from 0 to +2, therefore oxidation has occurred. While for oxygen, it went from 0 to -2. For it to be -2, remember electrons are negatively charged, therefore the oxidation number went from 0 to -2. Remember, reduction is the gain of electrons. So for it to go from 0 to negative charge, it must have had to gain electrons. So the oxidation number of O2 has decreased from 0 to -2, therefore reduction has occurred. And since both of them occurred, oxidation and reduction, it must be called a redox reaction. Okay, since oxidation and reduction has occurred at the same time, this is a redox reaction. So example CH4. So now first thing we have to do is assign oxidation numbers. Now CH4 we need to do by calculation. O2, remember the pure elements are always 0, so we can just write that straight away. Let me just do it clearer for you. CO2 is a compound, so we have to do it by calculation, and H2O is a compound, so we have to do it by calculation. Let's start with CH4. So the oxidation number for carbon plus, now look, there's a 4 here, so we write it here, 4 oxidation numbers of hydrogen, which equals 0. Now, the oxidation number for hydrogen, remember I put it in the table for you, is +1. So the oxidation number for carbon plus 4 oxidation numbers of hydrogen, which is +1, equals 0. Let me just put here for you CH4, so you know which one we're calculating for. So the oxidation number for carbon is +4, which equals, because it's 4 times +1, equals 0. So the oxidation number for carbon is -4. So now we calculated the oxidation number for carbon. We know that the oxidation number, so we calculated it as -4, and for hydrogen it is plus 1. This is something that's given, it's plus 1, and we just calculated the oxidation number. For carbon it's minus 4. Now we've got to do it for CO2. So let's do it for CO2. So the oxidation number for carbon plus, look, there's a 2 here, so we write it here, oxidation number of oxygen, which equals 0. Now we know that the oxidation number for oxygen is minus 2 unless it's in H2O2, but it's not in H2O2, it's in CO2, so the oxidation number for oxygen is minus 2. So the oxidation number for carbon plus 2 minus 2 for oxygen, which equals 0. Now we just complete the equation. Now plus 2 times minus 2, which is minus 4, which equals 0. So the oxidation number for carbon equals plus 4. So the oxidation number for carbon here is plus 4, and the oxidation number for oxygen is minus 2. Now for H2O, I'm going to do it this side. The oxidation number for hydrogen there is 2 hydrogens, so we write it here, plus oxidation number for oxygen equals 0. Now we know either for hydrogen or oxygen, we know the oxidation number, but just so you get the idea, I'm going to do it for oxygen. We know that hydrogen is plus 1 and the oxygen is minus 2. Now you can write them straight away, plus 1 and minus 2. But for people that forgot one of those, you can use either or. So let's do it for oxygen, it's minus 2. So the oxidation number of hydrogen is plus minus 2, which equals 0. So 2 of oxidation number of hydrogen equals plus 2. Now we've got the 2 here. So the 2 is times, so when we bring it here, it's divide. So the oxidation number for hydrogen, it's plus 2 divided by 2, which oxidation number of hydrogen equals plus 2 divided by 2 is plus 1. See, it's plus 1. Now we look at what we have. So carbon. Carbon went from minus 4 to plus 4. So the oxidation number increased. Okay, remember, oxidation increased, that means oxidation has occurred. For hydrogen, hydrogen here is plus 1 and hydrogen here plus 1. It did not change. With oxygen, so it went from 0 to minus 2. And here also it went to minus 2 on H2O. Or you can do it like this, or you can do it like that. It really does not matter. But the thing that you need to know that is the oxidation number decreased. Okay, so the oxidation number decreased. So here also we have a redox reaction. This is because the oxidation number of carbon went from minus 4 to plus 4, therefore oxidation has occurred. The oxidation number of oxygen went from 0 to minus 2, therefore reduction has occurred, and since oxidation and reduction has happened at the same time, this is a redox reaction. We then learnt how to write redox reactions. So for example, if we have the equation Cu2 plus going to zinc, this goes to zinc 2 plus to Cu. So first we have to write oxidation numbers. Cu2 plus, for monoatomic ions it is charged. Look, it's got 2 plus here, so the oxidation number of it is plus 2. For zinc it's 0. For zinc 2 plus, remember it's got a charge here, so it's the charge is the oxidation number, so it's plus 2, and Cu is 0 because it's a pure element. So now we can write the half equations. So let's look at zinc first. Zinc went to zinc 2 plus, right? It became zinc 2 plus. Remember, electrons are negatively charged. So if we remove electrons, the atom or the element's going to be more positively charged. So here we went from 0 to plus 2, that means we went more positive, then we have lost electrons. So remember, oxidation is loss of electrons, reduction is gain of electrons. So it went from zinc to zinc 2 plus, so it must have lost 2 electrons, okay? So this is where you write plus 2e minus. So zinc became zinc 2 plus and it lost those 2 electrons. So this is why we write the equation like this. And this is called the oxidation half reaction, okay? So electrons that are on this side of the equation have lost electrons. And then let's look at Cu. Cu2 plus became Cu. So it was 2 plus, it had a 2 plus charge and then became a 0 charge, okay? So 0, for that to have a positive charge and to become 0, it must have gained electrons. And remember, reduction is gain of electrons. So the Cu2 plus must have gained electrons, and how many electrons? 2, because Cu2 plus became 0. So Cu2 plus 2 electrons equals, it became Cu. So the electrons written on this side of the equation is the gain of electrons. So how do you write the overall reactions? This is what we just came up with. So this is the oxidation half reaction that we've just written, and this is the reduction half reaction. And look what we do. We first of all we cross out the electrons from either side. The electrons have to equal, because here we've got 2e minus and here we've got 2e minus. We can just cross them out. Everything that's written on this side of the arrow is written. So we've got zinc plus Cu2 plus, and then we write everything on this side of the equation, on the other side of the equation. So here we've got zinc 2 plus and Cu. Okay, so we write zinc 2 plus Cu. This is how we write the overall reaction. So this is an example of writing a redox half reaction. For example, we've got magnesium plus oxygen goes to MgO. So first, as we did before, we wrote the oxidation numbers. This is the example that I gave before. So look at the previous slide, how we came up with these oxidation numbers. Now we can write the half equations. So magnesium went from 0 to plus 2. So Mg, magnesium, went from, this is the equation, magnesium to magnesium 2 plus. Okay, so we look at the oxidation number to give it its charge. So it had a charge of 0, and then it had a charge of 0, and then it had a charge of 2 plus. So it must have lost 2 electrons. Okay, so it went from 0 to 2 plus, therefore it must have lost those electrons. So remember, oil ring, please always write these so you can remember, and that's oil is oxidation. Oxidation is loss of reaction, loss of electrons, and this is why we call it oxidation half reaction. Now with O2 it's a bit more difficult. With O2, it went from O2 to O2 minus. Okay, so let me just write for you again here. It went from O2 to O2 minus. We look at the charge, okay? O2, so here we've got oxygen here, and it went to, the oxidation number is -2, this is why we write 2 minus here. Now here we've got 2 oxygens. Here we've only got 1. So this is, to balance it, we have to write 2 here. This is why I've written 2 here. So here I've got 2 oxygens now, and here I've got 2 oxygens now. Now it went from a charge of 0 to a charge or oxidation number of -2. So it must have gained 2 electrons. So if the one atom of oxygen has gained 2 electrons, 2 atoms of oxygen combined must have gained 4 electrons. So this is why we don't write 2 electrons, we write 4 electrons. So the final equation will be this. Okay, O2 plus 4E minus goes to 2 O2 minus. Now we have to write the overall reaction for MgO plus O2 MgO. So this is the equation that we came up with before, and this is the equation we came up with. So this is the ones that we did in the previous slide. So to write the overall reaction, the electrons have to be the same. So this has to be the same as this. Now as you can see, here we've got 4 electrons for oxygen, and magnesium has 2 electrons. To make them the same, we have to times this whole equation by 2. Okay, so this will give us 2mg, 2mg goes to 2mg2 plus 4 electrons. So literally we are just timesing the equation by 2. 2mg goes to 2mg2 plus 2 times 2 is 4 electrons. And now we have got the same electrons, we can remove them. So we'll just take them off, and then we write everything that's on the left side of the equation of the arrow, and then everything on the right side of the arrow. So look, you can see here you've got 2mg here, written 2mg here, plus O2 here, plus O2. So that's all on the left side of the equation, and then everything on the right, 2mg2 plus 2mg2 plus 2O2 minus 2O2 minus. But then we have to, so this is not the correct form, so we have to change it a bit. So what we do is the 2mg plus O2, the first bit is correct, but after the arrow is not correct. So here we take the common factor. The common factor here between them is 2, so we put 2 here. And then what do we have is Mg2 plus and O2 minus. What we do with those is cross multiply. So we've got Mg2 plus and then O2 minus. And what we do is we cross multiply. So this will give us Mg2, O2. When they are the same like this, we just simplify them to MgO. So these cancel out as MgO. So then we've got the equation is finally 2mg plus O2 to MgO. This is the end of the semester review. I wish you good luck, and I hope you do well in your exams.